So welcome everyone. Thanks for coming. So today I'm extremely excited to be introducing Cynthia Brazil from MIT, where she's the director of the Personal Robots group at the Media Lab. Cynthia is one of the pioneers of the field of human-robot interaction, and she literally wrote the book on social robotics. Cynthia is also the founder and chief experience officer of Jibo, really the first social robot for the home that is an actual working consumer robot. And it's a real success story for moving HRI out of the lab and into the real world with real people. Jibo even made the cover of Time Magazine's 2017 issue on the 25 best inventions of the year. She has a long list of other awards and achievements over the years, with recognition by the National Academy of Engineering, as well as the National Design Awards. But rather than list a whole bunch more of these awards, I'll go ahead and hand it over to Cynthia.
Great, thank you. All right. Well, it's a pleasure to be here. I've had such a great visit, seeing old friends and meeting new friends and talking about living with AI and robots. So, you know, I started this work in social robots. I won't tell you how long ago. It was a long time ago. But the thing that is so striking to me right now is just who is living and interacting with AI today as part of our daily lives. I mean, even, you know, fairly recently, like with 2014, when Alexa was announced in December, there's like 43 million of these smart speakers in people's homes now. And with that, again, a profound shift in who is interacting with AI and just acknowledging there is so much opportunity and so much we still have yet to understand about what it is to live with intelligent machines when you think about the diversity of users, from young children to our oldest seniors and everyone in between. And I think quite a lot about the home in particular. You know, I'm sure you've all kind of heard the media quips of people like, oh, the future is going to be like the Starship Enterprise when you have this, you know, disembodied voice, computer, this computer, that. And for me, you know, it's like the home is a special place. I don't want it to feel like work. I don't want it to feel like I'm on the subway. It requires, I think, different kind of ways of thinking about the design and how you fit an AI technology into the place that is in so many ways your most intimate, important place. It's a place where people who you love live. That really makes me also think quite a lot about our future with living with these AI systems and what this is going to mean in these very important spaces like the home. And we know it's not fraught with without important issues, right? So this news article was very striking to me when it came out, 2017. So as you may recall, Mattel was going to basically create an Alexa-like talking speaker for the home, really catering towards not only young parents, being able to reorder diapers and things like that, but interacting with kids directly. And it went very far down the product development pipeline. It was about to be released for Christmas, and they pulled the product because there were just a lot of concerns expressed, not because of things that they knew were bad about this technology, but just we didn't know, right? We didn't know. So child advocacy groups, concerns around privacy, lawmakers, parents, again, which just kind of speaks to the time, right? So we just have to be very mindful about bringing these technologies into home and appreciating that as researchers and scientists, there's so much more to creating these technologies that we have to be aware of. So, you know, today we have these smart speakers. I would say in general, a lot of AI is designed to be very transactional in nature. It's very much like an intelligent tool to help you make decisions. But that's quite different from kind of the vision that I grew up with. You know, so growing up with Star Wars and thinking about these intelligent machines, not just as digital assistants, but really as these kind of sidekicks and these helpful companions that weren't just useful, but really connected to us on this human level. And they not only helped us do useful things that matter to us, they actually even helped us become the people who we aspire to be, right? And that was really the vision that I've grown up with of what this technology could mean to us. And the exciting thing is now these technologies are starting to come into real-world environments. We brought them into schools, looking at robots as language learning companions, into hospital pediatrics to work with child life specialists, to assisted living facilities, and now, of course, they're finally coming into the home. So again, what's the evolution of AI in the home? Is it going to be from this sort of transactional AI that we have right now and digital assistants? Will it become this sort of different vision of this helpful companion that's a much more kind of humanistic design? I think the crux of the matter is, again, especially when you talk about robots now, we still don't understand very much about this long-term interaction, right? When you talk about a research setting, it is hard, expensive, logistically challenging work to deploy these systems in the real world into real environments where they're interacting with real people, where you're innovating on the algorithms and the capabilities, as well as trying to understand what's the impact or benefit of these technologies on real people's lives. So this is just a paper. It was written in 2013. We actually did an updated version of this, looking at all the longitudinal human-robot interaction studies ever done. Many of them were basically not even innovating on the algorithms, just taking a commercial product like, a Pleo or whatnot into the environment and just looking to see what people did over time. And the punchline is there's just not a whole lot of studies out there. So there is a real need for this kind of work. And there's a real need, I think, for coupling this with the algorithmic innovation. We need better tools, we need better processes to really help galvanize and empower the field to advance this forward. And when I think about AI in the big picture, right, again, there's a lot of discussion around productivity and efficiency, the future of work, but I feel that the promise of AI will not achieve its full potential if it can't address these very deep human needs. So, I ask the question in a lot of my work, can AI actually help us to flourish? Not just to be more productive, but to live better quality lives and to be better people. And when you look at kind of operationalized frameworks around things like well-being, it's very clear that it goes way beyond the cognitive, right? You have to think about the social, the emotional, the sense of achievement and meaning. If we're going to create AIs that help us to live better quality lives, we have to create AIs that can engage and support us on all of these dimensions. And I would say, although there's a lot of work on the cognitive, the social emotional is relatively very understudied. What we are starting to find out is as you create these social robots, it's not as if they're like people who you're going to replace people or like other kinds of tools like smart devices. They're kind of this new amalgam of relationships that we kind of understand, but in this new kind of intersection, right? So there are attributes of these systems that engage you like a motivating collaborative ally, and I think that's really important. There are aspects, of course, of a robot that can be an internet cloud-connected tool like any other kind of computing device. That's kind of like a given. But the other thing that's fascinating is the way people naturally seem to want to relate to it as an other, where there's these attributes of being like an attentive companion animal, this sort of non-judgmental, affectionate, and I think you could appreciate in that video I just showed you, the nature of how people interact with this technology is very different than a tablet or a computer or a VR headset. It is this social, emotional, relational, connected other experience. And that actually can be very empowering for people if designed in the right way. So, in the talk, I'm going to highlight, this I think kind of the punchline of a lot of the work that I've done. So whether we're talking about a social robot or I think any other kind of technology that's trying to support human flourishing, is the more you can support people on all of these dimensions. We as human beings are clearly not purely cognitive creatures, right? We're deeply social, deeply emotional, deeply physical creatures. All of these things influence how we learn, how we make decisions, how we perceive the world around us, how we're influenced by events around us. But the more you can support and engage people in this holistic way, what we find is the more deeply people will invest in that interaction. And when people invest more deeply, they can often be more successful. And I think that's the punchline, is they can be even more successful with the technology than if you don't design to support this holistic experience. So I want to talk about, this is kind of touching a little mix of research and application, of kind of what is different about this experience with this social robot. And, a lot of times we get asked the question, still today, does it matter that it's physically embodied? Does it matter that it's a robot? Ironically, I would say when we first started this field, we would get papers just rejected from Kai point blank just because it was on a robot. And reviewers would say things like, why is it a robot? It's so expensive. Why not just make it a virtual agent? So the thing that we had to compete with against was basically a screen with a virtual avatar. Now we're having to defend ourselves against smart speakers. And I'm kind of like, that seems like a huge, several steps backwards. You're taking even more impoverished stimulus, and you're asking us to validate ourselves based on that. So again, I guess that's just a lesson in kind of combating ubiquity, right? Once you're ubiquitous, then suddenly you don't have to fight these battles anymore. But we get asked this question a lot. So what is it? What is it about this social co-presence? Does it actually really matter? So I want to present work as a kind of a case study in work that we've been doing in pediatrics. This is a long-standing collaboration with Boston Children's Hospital, where we've been working with child life specialists. And child life specialists are professionals who are trained to address the emotional support and needs of children patients who are in the hospital, but also that of their families. And the question, of course, is, not surprising in a lot of these domains, there are not enough child life specialists to meet the demands of the patient, admitted patients. And so the question of how can you create a different kind of technology that is an extension of the child life services team that helps them basically do their job in a more scalable, effective way is actually really, really interesting. And I'd also say another kind of side effect of that is also how can you extend that quality of care to the home? Because you can maybe provide exceptional quality of care in the hospital, but they need to be able to continue to engage patients at home, and they have no way of doing that. So again, the notion of a robot, of a different kind of technology to do that, is really, really interesting to them. So this is just a video that was done by the New York Times, kind of giving you a little bit of color on what this looks like.
A patient like Beatrice who's got a chronic condition, she's going to be in and out of the hospital. She's here for procedures. She's here for doctor's visits. She's missing school. She's missing her friends. She's really not doing any of the things that a normal kid her age is doing. And what we want to offer kids like that is just one more way of helping them to feel okay where they are in what's otherwise a really stressful experience. I think there's a way of connecting with kids that's different from what grown-ups can offer. They have incredible imaginations, and they can really suspend disbelief, and there can be a true relationship that develops between Huggable and a patient.
Hi. Hello. See. Perfect. There you go. Is that better? Oh my God. Hi. Hi, Huggable. Hi, Beatrice. You're adorable. Oh, thank you. It's very nice to meet you. Do you want to play a game? Yay! Let's play a game.
All right, so what we have here in this case is that we just finished a clinical trial. We have a child life specialist who works in the room with one of three interventions. So we compared the physical robot versus as kind of plug compatible graphical version of a robot on a tablet versus standard of care is a plush. The social agents is teleoperated by another child life specialist. There's a lot of reasons why we do that. One is just because we want to make sure that the quality of care is present. We also want to collect a lot of data to understand what is the phenomenon of having a robot in this kind of context that we can then think about what are the AIs, what are the opportunities to create more autonomy for this. So we often start projects with this sort of teleoperation paradigm to begin with. We get a lot of insights from that. So we just finished a clinical trial comparing these three interventions, which I think one of the things that's nice about this study is the child life specialist in the room is doing her job to the best of her ability with each of these interventions. And so in many ways, all three of them are socially animated, whether it's a remote child life specialist teleoperating the virtual bear or the physical bear, or if it's even the child life specialist kind of puppeteering the plush with the child, right? So all three of these are animate one way or another. So, we looked at the difference between these technologies across a lot of different dimensions where we were particularly interested in the social emotional factors. If you're going to try to create a technology intervention that can engage children and improve their their emotional experience. We were very interested in looking at that. We were interested in looking at engagement, how often children would speak, because if you want to engage a child in a sort of health protocol in the hospital, their engagement and cooperativeness is very important. So if you look at these different charts, what we see is, for things like total joyful semantic affective analysis, sentiment analysis on the utterances that the children would speak over time. We see that the positive effect increases over time with the physical robot, but it even decreases over time with the virtual robot, and the plush is kind of the lowest. When we look at shared attention, so the ability for a child to be not only engaged in the technology with the other people in the room, you can imagine for a child life specialist, this is important. You don't want the child just having their face in the tablet. We say a lot more joint shared attention when you have the physical robot there. When you look at just the amount of utterances, you see children are talking more over time, and we're seeing that with the robot over the avatar or the plush, and we see that the cooperativeness is also high with the robot as well as the avatar. And then when you look at these other social attributes like the affective touch, the social touch, people may be throwing the plush across the room, they may be poking the tablet. With this robot, all of the touch is a social relational touch, and I think you see that's in the video again and again and again. So, in the hospital, the clinicians they talk about emotion as the fourth vital sign. And they say this is so critical because we have all this equipment to measure all these other biometrics of the child, but the emotional state of the child affects everything, from the recovery rates to their compliance, to even how long it may take a child to give you their arm to be able to give them a shot, for instance. So they're very, very, very interested in trying to come up with new technologies to continually monitor this and engage children in new ways. We've been looking at the opposite side as well. So as another example of kind of this emotional lift.
Well, despite, or maybe because
now
of
that
technology
Jibo's
and social
out
media,
there, we're
life
seeing
in the 21st
people
century
putting it
can
in
be
different
isolating,
situations.
sometimes lonely for people. That's especially true with the elderly. But Chron4's Maureen Kelly discovered that some who are in assisted living communities here in the Bay Area are finding camaraderie and fellowship through robots.
Hey, Jibo, can you dance?
Let me put on my dancing shoes.
Wow. That was wonderful.
Now, you don't think
A
of seniors
resident
as
of
being
the
adopted
Alma
as a new
Via
technology,
assisted
right?
living community in San Francisco is meeting a new regular visitor here. It's a robot called Jibo that's being used as part of a pilot project among the several Bay Area facilities run by Elder Care Alliance. In addition to dancing, it can play the radio on request, snap photographs,
Oh, that's a
So it's a
beautiful
platform
picture.
with skills.
tell jokes,
What did the snail say when he was riding on the turtle's back? Whee!
and react to the human touch. It purrs when petted. He also often has some quirky responses to questions.
Hey Jibo, what are you?
I am a robot, but I'm not just a machine. I have a heart. Well, not a real heart, but feelings. Well, not real feelings. You know what I mean.
Erin Partridge, a researcher and art therapist with Elder Care Alliance, takes Jibo with her when she meets with the seniors. She says this is not a case of caretakers being replaced by automation. Instead, they're using this cute piece of technology to encourage their residents to connect with each other, despite some needing different levels of care.
So when we have something that all of us are experiencing all together, maybe for the first time, right, meeting a robot, we've got a focus point where we can all meet right here in this moment and have an interaction, then it breaks that down, right? And it doesn't matter that this person has dementia or this person maybe has Parkinson's and has some trouble talking. We're all meeting together as humans and robots.
Can you see him? He's wiggling his fanny.
Jibo inspired some giggles and guffaws amongst this group here.
When you get this age, you should be able to laugh more and more.
What it does, it brings that out of us. That's part of the miracle of it. And that's part of the miracle of living as far as that goes.
So that was very poignant for me. So again, it's about this emotional lift of engagement that's just very different from how we engage with other technologies, but it goes even beyond emotion. So again, if you look at a number of these systematic comparative studies, comparing a physical robot to even a video of a physical robot, so you know it's real, but it's just not right in front of you, to a graphical agent of the robot, to a disembodied voice, what we see is often these robots actually do quite well. So if we look at all these interpersonal dimensions that lead to kind of social judgments that have a profound effect on people's acceptance and engagement of these technologies, the robots score quite well across trust, attraction, empathy, engagement, persuasiveness, all of these kinds of things. So again, there's something actually very important going on about the physical embodiment of this kind of technology that's just engaging people more deeply in a different kind of way. So the second theme I want to touch on is, again, this notion now of this collaborative allied engagement and how that's enabled with not just this voice interface, but this kind of interpersonal UI, this richly multimodal interpersonal UI, and thinking about, you know, beyond just interface to sort of building this working alliance and building this sense of rapport, which again, when you collaborate with someone who's an empathetic other, that's very different than a useful tool that you're using. And we know from human social psychology, right? I mean, we've been developing these learning companions for children for about 5 years now. There's a lot of social outcomes that you can look at as well as educational outcomes, and they're all kind of tied to, again, this social engagement between people and other people, but in this case, people and robots. So again, just appreciating there's a holistic kind of wrapper of the nature of engagement directly impacts things like learning, attentiveness, attitudes, and so forth. So, you know, we do a lot of data collection, right? So, you know, there's a lot of excitement right now about deep learning, and, you know, there's certain kinds of data sets that are vast and you can label them, but there's a lot of important data sets that frankly don't exist. And these kinds of data sets that are richly multimodal don't exist. And when you think about underrepresented populations like young children, there's a dearth of data around this. So this is just kind of a little montage to show you a little bit about our process. So if you want to design a robot that engage in this nonverbal dance while engaging children in a storytelling experience, we collect the data of what it's like to see children actually tell stories to one another. We run various algorithms to do automatic effective computing and pose and all that kind of tracking. And then we use that to basically try to develop these computational models by which we want to basically embed that model now in a robot, put it in the same context with a child, and see how well does that model perform. Is the model actually really capturing the interaction that you saw with the two children, right? So we do a lot of this kind of work. And these nonverbal cues and the synchronicity and the contingency turns out to be very important for how children engage and see the credibility of the robot as an informative other to learn from. So again, all these social judgments come along with this. That's really important for engaging the children as a learner. So I want to just quickly touch on one project that I think, you know, from this video really highlights this different way of engaging a technology, right? So this is a learning companion, Tega robot. We designed a series of educational games. This particular game is called Word Quest. The child and the robot, they play the game collaboratively. So the robot actually plays the game with the child as they take turns. There's a challenge word presented that's, you know, a pretty hard word for a preschooler, like crimson or garment or something like that. And their task is to go through, pan through these story scenes and trying to click on objects that match that challenge word. And what I just want you to kind of notice from this interaction is based on a reinforcement learning system to learn a policy of engagement, how these other aspects of the collaboration are coming out of this encounter.
Lavender. I'm lavender. Oh,
what are we trying to find?
We are trying to find lavender color stuff.
Okay.
The
word was lavender.
Yes. And what is lavender though? What's lavender? Well, that's blue. What is lavender? Girl, jumping.
I'm sure you will do better next time. I believe in you.
Robot's turn.
Time to perform. Lavender is purple.
Yes. Just like my friend loves lavender. Ooh, that's
Flower.
Ooh, I believe
All right, so there was a moment in here where you could hear the robot express confidence in her. I'm sure you'll do better next time. I believe in you. If you heard her say very quietly, she mirrored that back to the robot. So this is another really important phenomenon we're seeing is when an AI engages people, certainly children in this case, but we see it across different generations as an empathetic other. You get all other kinds of aspects of social modeling. And so in this case, the child was modeling empathy and a growth mindset back to the machine, right? So, as a socially influenceable technology, this is something that is definitely something we need to really understand. We're using it to try to benefit children, but of course, this is something that could be applied to not benefit children, right? So again, just to say there's a lot of ethics and a lot of things we need to understand about this work. What's actually happening is that we're applying reinforcement learning to figure out a policy by which the robot decides whether it should play the role of an expert, or it may be defining the word for a child, being able to demonstrate its understanding of why an object matches a word, or a novice whereby the robot may ask the child questions, the robot may make a mistake on purpose and ask the child why it made the mistake. We basically compared, based on these 3 reinforcement learning models, always being an expert, always being a novice, or this adaptive role where it switches between the two. Looking at children in the Boston public schools, we recruited schools, especially with kids with high ESL populations. They play this collaborative game where they learn 5 words in the first session, turn taking, and then 6 of these challenge words in the second session. You can see the challenge words here. They're things like azure and gigantic and stuff. And interestingly, we can see the benefit of having this adaptive role. So it's actually better for the robot to not always be the expert. What we actually find is that if the robot's always an expert or always a novice, children actually start to kind of not pay attention. But when the robot keeps switching it up more like an actual peer-like companion world, they notice when the robot makes a mistake. They engage more and notice when the robot's asking a question, they answer, right? So again, understanding this role in the relationship and how that impacts children's not only engagement, even the learning outcomes here is really interesting. And what we find is that children who even scored the lowest on the pretest had the largest gains from these 2 sessions with the robot. So again, this is just a single shot per session of these words with a pre and post test after and a delayed post test. I could imagine that, of course, if you had repeated sessions like this, complementing that in the home, children would score very, very high on this sort of challenge level. And we think about, kind of rules of thumb of game design. There's usually this kind of 80-20 rule of mastery, things you already know versus the new challenge words. All of these words are hard. And the fact that children engage through all of them and store this well, I think this is something that's worthy of a further understanding of it. Through this relationship, can you actually have children accelerate their learning, challenge them harder because they have this empathetic other than if they just play the game by themselves, for instance, right? So these are the kinds of questions we're trying to understand and dig into. But again, very promising, very exciting when you think about this different kind of engagement. The last thing I want to touch on is personalization. So the promise of AIs that live with you, can learn about you, can optimize their behavior to yours to achieve a learning outcome. This is another project that's around early literacy language learning. And this is just to say how important this is, right? So you're noticing a lot of work we're doing engaging young children. The reason is there's just too much data showing that if children don't even start kindergarten ready to learn, it's very, very, very hard to catch up. So right now in this country, 60% of children do not attend a quality preschool. And 37% of 12th graders in 2015 can't even read at or above the proficiency level for their grade. Now, when you think about the future of the workforce, do you know a single scientist or engineer who can't read at grade level, right? And so the concern and the worry, of course, is that die is getting cast way too early in a child's life. So, people like Benjamin Bloom found this 2 sigma effect that argues being able to learn at your own pace, to be able to demonstrate mastery before you move on, having one-on-one personalized sessions is the most effective way to learn. The problem is it's not scalable and it's not affordable, right? But with AI, that can change, right? So this is another example now of learning oral language and vocabulary with a second language or with an early literacy robot, where the robot engages with children over a period of 3 months. So now we're moving into long-term interaction of repeated encounters, where the robot is learning a personalized model to each child. The robot engages in a relational fashion.
Nice to meet you.
We've been developing new measures of how you measure this relationship between children and the robot and how that affects learning efficacy.
Ariana, cool.
The robot learns their name, refers to them by name, talks about past interactions, talks about future interactions. And it's a storytelling and story resharing paradigm where the robot tells a story, asks questions, says dialogic question asking.
All day. That's what you see in the rainforest. Do you know what sway means?
No.
Sway means go back and forth.
So we know how parents tell stories to children. This dialogic question asking is critical for the best learning efficacy for children. So the robot engages in this way, asks the child to retell the story. We capture a ton of data. We're capturing everything the child says. You can notice she's wearing E4 sensors. We're capturing biometric data. We're capturing her facial expressions across all of these kids to create a very rich corpus of data that we're trying to basically learn through reinforcement learning again, a model by which the robot can predict of this library corpus of 72 stories that we can level by complexity. What is the optimal next story for the robot to tell the child to promote their vocabulary and their oral language development, right? So that's the task at hand. So this is just some data showing that this is the confusion matrix showing that the system is definitely learning a different policy per child. The models aren't converging yet, but the question is, does this actually impact the learning outcomes, right? So if we look at measures of the oral language gains, we compare the personalized policy versus the non-personalized. We see an accelerated rate at which children are developing new oral syntactic categories. And again, we see big differences in vocabulary gains between the personalized robot versus the non-personalized robot, which is still a gain over baseline, right? So again, a lot of promise when we think about innovation of new technologies that engage different demographics, different diversity of needs around these kinds of technologies that are really designed in a way to try to match the way this particular demographic learns and engages, right? I think that's the big punchline. So when we look at this kind of work and we think about the bigger picture, there is a real opportunity to think about, and we hear this again and again when we engage our stakeholders, we can provide exceptional quality of care in our institutions. What we can't do is continue that and engage it at home. And yet, if you could do that, you would have much better outcomes for their stakeholders, right? So whether it's education, you learn at school, how do you continue that at home with an effective personal tutor for whatever the subject matter is? When you talk about, an assisted living facility, they will tell you point blank, we cannot build enough facilities to meet the silver tsunami that's coming our way. We have to be able to engage people in their homes as they age in place. When we think about chronic disease management, health and wellness, same story. But even when we talk about high-touch, short-term encounters, there's a lot of interest around a technology that can engage people in this humanistic way. So whether you're talking retail or hospitality, et cetera, there's a whole wealth of possibilities and opportunities for a technology that can engage people in this humanistic, personalized, high-touch way that we're just starting to scratch the surface. So the last thing I want to talk about is a comparative study. To my knowledge, this is the first study of its kind where we compared digital assistant, talking speaker, kind of transactional AI in the home as it is today with this sort of relational AI social robot. We use Jibo because it's the one social robot out there that actually has the features and functions that we can actually do a comparison with something like Alexa. So people are starting to live with social robots too. And the pictures that people are sharing with social robots look a little different than I think the pictures people share with Alexa. People are definitely engaging with this technology and they talk about it as being like one of the family, which again I think is quite different. So different kind of AI, different model, different kind of bias in how it's designed. How do these different generations from children to adults to older adults live with these different kind of voice-based agents in the home, and what are the implications for how we should design these technologies? What are people's preferences? What are their boundaries? So, this is just a fun video that just kind of highlights the difference in the design stance of these different technologies.
Hey Alexa, tell me about yourself.
I'm Amazon's Alexa, designed around your voice. I can provide information, music, news, weather, and more.
Hey Jibo, tell me about yourself.
Okay, sure. My name is Jibo. I'm a robot.
My favorite things to do are talking to people and dancing. I also really like Abraham Lincoln because he was so honest and because I like his hat.
Okay, Google, tell me about yourself.
I'm your Google Assistant. We can play Mad Libs. I can tell you a joke, or you can spin the wheel. What's your pick?
Okay, so again, just to highlight different design philosophies behind these technologies. Now, when we do this comparison, I mean, it's nice in that each of these technologies has offerings in each of these categories, from the functional kind of utilitarian skill sets to entertainment, things like music and games, to social companion, which could be things like jokes, greetings, asking the agent about itself, right? They all have offerings in all of these things. They're just weighted differently, right? We actually had people do a personality test for these agents. And of course, you can see people actually attribute very different personality profiles to something like Jibo versus something like Alexa, where Alexa is seen as more conscientious, consistent, and predictable. Jibo is seen as being more open, more extroverted, and there's more empathy and emotiveness, obviously, in the Jibo experience. They're actually quite similar in agreeableness. So again, this is just to say different design philosophies, different emphasis in the features and functions. So we did a two-phase study. We did a study where we first brought people in before they interacted with the agent. These people had not experienced or had an agent like an Alexa or a Jibo at home. And we had them look at what their kind of perceptions and attitudes of features and functions would be before they lived with the agent. Then we said either half of the people got an Alexa or half the people got a Jibo. They lived with the agent for a month. And then we looked at differences in engagement and difference in perceptions about how that would change after living with the agents of the kinds of roles and features and functions they thought they'd want after the fact. We looked at children, which we defined as 5 to 17 years old in our sampling pool. Call it younger adults, adults 18 to 49, and then older adults 50 years and up, right? So these are the three demographics we looked at. And this is a rough distribution. So you can see that, in our older adults, a lot of them were more like 50s and early 60s, but we had one 98-year-old, and she was awesome. Okay, so this just gives you a sense of the distribution of age profiles. So, when we did our initial kind of cultural probes and needs finding, we had all these cards with all these different features and functions that, if you were going to have an agent like this, what would you want it to do? And we had people put these colored chips on the cards that basically indicated preferences, which is like, I would like these things, and I definitely would not like these things, right? So this is all about first impressions, right? And, this was fascinating, right? So we look at children and adults, and then we look at older adults. Older adults were the most open to the broadest range of features and functions. Adults were the pickiest. I wouldn't have expected that. I would have thought that the older adults would have been the most conservative, but they were the most open. And this is to say in these different categories of things like reminders and information and suggestions, agent sharing something as a proactive agent, something it thinks is interesting, versus somebody trying to reach you, kind of mediating social interaction, or somebody through social media sharing something. We see that, there's a lot of nuance here, right? So the red is things that people didn't think they want. Clearly, suggestions were the most kind of polarizing kind of topic area. But it depended on what the agent was sharing. Reading, writing, kind of things like that. Sharing something new people were open to, but they didn't want the robot letting them know they should take a nap, right? They didn't want the sense of their autonomy being kind of challenged by this kind of agent. But again, if you look at the different generations here, you see that older adults are the most open to a whole range of features and functions across these categories. That was fascinating. Now, we had people take very detailed logs over the first 14 days. We didn't ask them to take logs of the second 14 days. So what we did over the 1 month is we tracked detailed usage in the first 14. Even by just the color distribution of these two plots, you see something very interesting, right? Here's Alexa with younger adults. This is Jibo with older adults, right? It's like the flip. Really fascinating. And then when you look at kind of a 5-day running average, we see these trends of usage over time, which were also really fascinating. So it seems that the younger adults want to anchor their usage first in the utility. And if you deliver enough utility, they'll start to use these kind of social and these kind of companionship entertainment things later, right? Whereas children and seniors were the opposite. Children mostly wanted entertainment, But if you couldn't anchor it in the social and emotional for both children and seniors, you didn't get as much usage overall in the utility, right? So children were around the social entertainment, and older adults were even more, right? So again, this is fascinating to me in particular because this is where the social robotics is really coming through, right? It's not as if Alexa didn't have social entertainment functions, but there was something about the way the robot did. And arguably, you could say Alexa had many more social and entertainment functions, 10,000, 30,000 skills, right? But there's something about the nature and the quality of the engagement that was different enough that really got the traction between the older adults and the children. Now, if you look at the change in these different categories over time of what people, after the 1 month, what they thought they wanted, we see that suggestions is even more polarizing, right? So that's to say that you may have a stakeholder pool where suggestions like medication reminders and things are actually really important. But this is to say that the way you do them, I think, actually really matters. The groups or the functions that had the most positive change, what people wanted more of, were these socially driven categories, right? So although I'd say in a lot of these assistants right now, there's a lot around utility, after living with these agents for a month, these socially driven categories were the most kind of, that's what people wanted more of, right? And then we had this interesting construct called the wish jar. So we had these little wooden tokens that at any point during the 30 days, you could write a little thing about what you want the robot to do or agent to do, what you didn't like, whatever, just some sentiment about the experience. And we collected them. And when you look at Alexa, you see kind of a consolidation of topics around, a lot around functional, some around humor, they want Alexa to have a better sense of humor, some around movement, and then some around proactivity. But interestingly, when you looked at the social robot, people's expansiveness in terms of what they wanted this agent to do and fit in their life was much more diverse. So that's fascinating, right? It's like this is a much more narrow categorization of how they see this agent fitting their life. The robot potentially has a lot more headroom in where it can go. So again, just fascinating stuff. So the last thing I want to talk about now is this bigger societal question of who creates with AI, right? We're talking about people living with AI. We're talking about more vulnerable populations living with AI. Other institutions, organizations are building these AIs for these people. But when only a small fraction of a society can design with these technologies almost by necessity, it's only going to be applied to address the needs of a small subset of society, right? There's just going to be inherent bias there. So how do you democratize who creates with AI? For me, it all gets down to education. So we're starting to look at AI education for even starting at preschool. So pre-K through 12, where our sweet spot right now is pre-K through like 12 years old. And the reason why is because when you can have children, first of all, they're living with these technologies. You want them to understand them, appreciate the way they think, to be able to feel the right relationship and empowerment over them. But you want children growing up with an attitude that AI is something that not only they can understand, but they can actually create with. And so we've been building on top of the Scratch platform, adding extension blocks to things like Watson and Clarify and Hue Lights and robots like Jibo and Cosmo to empower children to code these systems, to train their own models for these systems, and then to put those models in new experiences of personal significance for them. So this is an example of an exercise, the kind of warm-up thing we have children do, where first they try to come up with an algorithm or code in terms of what can we say to make Oscar react to what we said. And they realize kind of how like time-consuming and the instances are explicit, and then we invite them to do it with something like a classifier system that they can train, right? So this is just getting their heads wrapped around how do classifiers work, why are they interesting, why might you want this to do it, make it more generalizable. And then we have interfaces we're developing that kids can actually come up with what are the things I'd want to actually put in the training set. So, you know, having Oscar be happy to kind things you say, or having Oscar act sad to mean things. But even kids wanted to create backhanded compliments. So you see like the way kids are thinking about these things is fascinating. And so this is giving them hands-on experience into what it's like to create these systems. So this is a quick kind of summary video of the platform. It's very much a research project. It's not just for kids, actually. It's for families, too, because parents have these things in their house as well, and they also need to understand them. And we're trying to understand how to create experiences that parents and kids can also do together. So again, it's kind of this scratch blocks-like programming, but you can see a diversity of blocks, right? There's Clarify, there's Jibo, and there's Alexa. So kids are being able to create these custom IoT AI experiences across a big kind of palette of these AI-based technologies. So we allow them to train models.
He's going to learn what those pictures are going to be.
Do you think computers already know things, or do you think people teach it?
People.
What you just did was teach a computer how to do something, right?
We taught a computer? Sometimes a computer teaches me.
It's like mind blown.
To make a computer recognize colors.
So like he's 10.
And labeling them as colors. So like
I like his bow tie.
I'm gonna put my balloon here, take a picture, and label it as green, so the computer can recognize green.
And so they're able to explain how they're training these models, and that's important too, right?
Here's what you were saying, and it reacts to it.
You have to say like what text is bad, and what text is happy or maybe backhanded, and over time it will be able to recognize it without you telling. Bad dog. Good dog.
So again, and through the process of building these projects, kids are talking about how the systems work, how they need to change the training set, why the model's not right yet. They're able to work collaboratively, they're able to articulate their ideas, they're able to think creatively and systematically. So basically they're learning a whole bunch of 21st century learning skills as well, which I think is really critical. So we have an opportunity. So last week, I think, was the week that the Computer Science Teaching Association partnered with AAAI around AI education. And there's been a very grassroots-led teachers movements to bring computer science education into K-12. I think with that there's an opportunity to bring AI education into K-12 and to really create the curriculum and exercises from the ground up that's very hands-on, collaborative, getting children to tinker with this stuff, to think about this stuff, and to build those 21st century skills that we all want our kids to have. So they have access to these opportunities, these incredible opportunities in this time that we live in. And I think this is critical because, if we want truly humanistic AI, we need to empower a much greater diversity of people to create these technologies, right? Because it's people from their different walks of life that have the empathy and the appreciation of the challenges and the opportunities that matter to them in their communities. So whether it's creating relational AIs that are supportive of people in this kind of personalized, empathetic other, or whether it's these kinds of educational initiatives that empower a much broader diversity of people to create with AIs, kids as well as adults, and I would argue even seniors. I think this is how we're going to get to AI that can truly benefit everyone and not just the few. All right, so I'm going to end there. Thank you very much. Do you want to do questions?
Yeah. I think there's time for questions.
Questions?
Yeah.
Okay.
When you were talking on your prior work on allies and personalization, were the older adults, I don't know what you lonely, or they were alone, were they in a community?
In the assisted living video?
Yeah.
Yeah, so that was...
I wonder if that played a role into being more open to the technology as opposed to the professionals and active.
Yeah, so I think I think what you're seeing from the in-home 1 month study in general was, I think, the lesson to me is older adults and seniors, they do understand that technology can help them and empower them, but it needs to be designed in the right way. So they're open to it. But, there's a lot of stuff that are designed for them that isn't necessarily stuff they want to use. So I think that was clear in the assisted living facility, where actually the thing that was compelling was it was a practitioner in the facility who had the intuition that this technology could enhance the way residents would engage with one another. So it was not and they made the point in the story, this was not about replacing the practitioners. It was really about saying, if we introduce this other kind of technology, can we spur a richer community collaborative connection among the residents? So that was the hypothesis, and that study is continuing to go on. I don't think it's because they're lonely. I think it's because they see technology as something that can really help them. It just needs to be designed in the right way.
Oh, there's a recent case where like kids were mistreating Alexa, and I think they added in the new word "please, Alexa." Is there anything about this approach that might discourage or make kids want to treat the agent more respectfully?
Well, so I think, again, we're in this very intriguing time, and especially with these social robots, where children are engaging them more like an other versus a device. And what we see is because of that, children, I'll give you an example. So we did a study last year when we just did the longitudinal study we're finishing up now, looking at children learn all kinds of things from others. There's kind of this more curricular stuff, but there's also things like attitudes, like a growth mindset, fixed mindset versus growth mindsets. And children acquire a mindset based on how adults often or teachers praise them and speak to them. So if parents and teachers reinforce that, oh, you're so smart, then the concern is what happens when things get hard. Do they assume like, oh, I'm just not good enough anymore? Or if they praise effort, and that's how you learn, that's the growth mindset, right? So we designed a puzzle-solving game where we had children play the game with either we call it a neutral mindset robot, because we thought a fixed mindset would be unethical, a neutral mindset robot that would just make factual comments about the state of the gameplay, versus a growth mindset robot. And what we found was that the children who interacted with a growth mindset robot self-identified greater in the post-testing of having a growth mindset. And on the intentional parts of the task where we challenged kids and actually made them fail, they tried harder and they demonstrated more grit. So, and even in that video I showed you where the robot says, I believe in you, when she got it wrong, and you heard her say back to the robot, I believe in you, we see this social modeling phenomenon again and again and again and again. I would say at this point I think it's quite robust. So, and we're starting to explore that phenomenon in empathy. Can you actually have social robots engage children with, a known issue with bullying to have them become more empathetic? So that's just to say that engaging our social, emotional processings and behavings, I think this is a technology that clearly can do it. It can be applied, I think, to really help kids. But then it needs to be done in a really ethical, responsible way, because clearly, children are engaging those parts of their brain when they're engaging with this technology. And I think it's not just kids, it's people of all ages. So yes, I think it's important that these technologies model the kind of behavior that you want, because I think it actually helps reinforce the kind of behavior we want to see in each other. So I think there's an opportunity there.
So thinking about the transactional versus social robot comparisons, right? Even in conversational systems like chit-chat systems, it's been very hard to pin down good reward functions that reinforcement learners can actually use. So in the two examples that you pointed out, I'm curious, how robust do you think the reward functions were, or how good?
Yeah, I think it's early days, right? So I can say that what we are doing is those inputs are going into the reinforcement learning algorithm, and something it's trying to optimize. So we're looking at effective computing inputs, the biometrics for engagement. We're looking at their responsiveness to the robot's dialogic questions. We're looking at whether they get things right or wrong. We're looking at their language samples. And so we're trying to both use reinforcement learning to kind of simultaneously maximize engagement as well as these learning outcomes. And we're seeing promise. I think, these are early days. I think that the point of showing the slides is this hasn't been done for kids this young, first of all, right? And building a technology that addresses these social, emotional, nonverbal things hasn't been done for kids like this, right? So the fact that you can even show boost on both the dimensions is noteworthy and important. It's just to say there's probably a pony in there, right? A lot more work needs to be done. And I think that's kind of the state of the field right now. It's like we're starting to see a different way of engaging the human mind and behavior that is actually, I think, quite profound, right? This is no longer about naturalness. These are deep social processes that this technology is able to tap into, right? And so this is kind of like, this is not shallow, this is actually quite deep. And we need to understand it, and we need to think about how it can be leveraged to benefit people, and we need to be able to create best practices so it's not used to, obviously try to make people do something that's to benefit a third party and not the person themselves, right? So it's just to say, we live in interesting times, but we are seeing a very kind of, provocative psychology happening here. And again, it runs deep. And I think the more we do this work, we're discovering how deep it actually goes.
A lot of the agents have this novelty effect. Like when the kids see it, they get super excited. And it is hard to make it permanent, like build this longer term friendship with them. What are your thoughts about this continued engagement, how you can actually form bonds that go beyond the novelty?
Absolutely. So, I think you can see in a number of these studies, they're longitudinal, so they're going well beyond the kind of novelty effect. I actually think in our field, we need to have a real deep systematic investigation of what we mean by the novelty effect. Because, when I was first a graduate student, it was like a 5-minute encounter before you started the task was enough to address the novelty effect. Now it's like 2 weeks where you haven't addressed the novelty effect. So we just need to be much more rigorous in what we mean when we say the novelty effect. That said, when you're interacting with the system over 3 months or a month every day in the home, you're past the novelty effect. So it's a combination of things. I do think, there is definitely, you need enough freshness in the activities. Or it's like no matter how compelling Angry Birds is, it's going to get boring at some point. So you need enough variability and freshness of the activities to sustain any sort of encounter. I think these relational things are also really important. So the fact that the robot, whether it's Jibo or Ortega, are actually doing these social grooming functions, greeting you in the morning, asking you how your day was, remembering that, personalizing that to you, commenting on, did you have another good night's sleep? Or I'm sorry, I hope you sleep better tomorrow night. Did you sleep better tonight? These things matter. And I guess that's what we're finding is the personalization combined, I think, with the, again, the supportive, empathetic other actually matters to people. So I think it's a combination of those things. And there's other things as well. I think, but, we're at the very, I think, beginning of understanding how you design for sustained relationship, and you're starting to see mechanisms we're exploring here. It's hard to do this work. It's hard to deploy these systems, like these robot systems in people's homes for a long period of time to collect the data. It's just hard. It's logistically hard and expensive to do, but it's important work that needs to be done. It's just to say there's a lot of opportunity here, I think, and very poignant. But just like interpersonal interaction, I think there's a whole set of processes that are at play to build that sustained sense of not only just engagement, but that kind of relationship that you feel like you're actually working with the other or for a sustained period of time to reach a goal of personal significance. And I think that's also part of it. So,
I thought your part about the AI tutor was really, really interesting. What are some of the next steps that you see applications for an AI tutor given the technology that we have right now?
Yeah, so obviously, computer tutors is a huge field. I think it tends to be applied more towards older students, and seems to be tended to apply to more towards like math and physics and kind of STEM, explicit STEM areas. We were going after the younger, early childhood learning for a number of reasons. One is just it's a critical time to intervene, as I talked about. It's an underexplored area for technological innovation. Children at that age just learn in a very different way. They absolutely learn from friendly, empathetic others. That's how they're wired to learn, so you need to design to support that. I think there's a whole host of things we need to address around early childhood learning, around early math and literacy, and even, the fastest growing demographic entering our public schools are English language learners, which is why we are going out to recruit from schools with high English language learning populations. Kids with special needs is another huge area, right? So whether it's attentional issues or ASD or whatnot, I think there's huge opportunities for, again, kind of giving everyone the best possible chance of being successful by addressing a diversity of learners. That's where, I think a lot of high impact opportunity is. On the flip side, I think you can look at workforce retraining, and with all that kind of concern about AI replacing our jobs, I think there's a huge opportunity for AI to actually retrain us for new jobs. So I think that could become another kind of huge impact area for education. There's a lot more discussion around kind of lifelong learning as well and continuing education. So it's all important, But for me, just after looking at all of the data and all the unmet opportunity, it's the early childhood stuff. The fact that the die is being cast for way too many children way too early in their life, it's just not right. So I do think that's going to be the biggest kind of social justice area of intervention for education. You want to ask one?
Yeah, I had a question. At one point you were showing how people perceive the personalities of Alexa and Jibo.
Mm-hmm.
And I'm wondering for Jibo, like how did that match like the intended design of Jibo's personality, or is there anything that surprised you there?
I think that did match, I think, the kind of design stance of how Jibo was designed. I mean, he's designed to be open and extroverted and to, convey and elicit this emotive kind of empathetic response. We would like it if he was perceived to be more conscientious. Some of that's just technology continues to improve and evolve, but, and he just doesn't, he doesn't have 10,000 skills yet, so there's some of that at play as well. But in terms of, I think, again, the punchline for me of especially that working average of seeing the trends is to say that's where the social robotics is really showing up, because Alexa has arguably more offerings in all of those categories than a product like Jibo that's only been on the market a few months. And yet, you see this different in engagement. That's the social robotics coming through. That's a different way that the robot is showing up to people in their lives that's leading to that engagement. I think this is something the field or even the consumer landscape and corporations have yet to really grasp, is that this is actually this is different. This kind of experience is quite different. And it's appealing to a diversity of users, right, that I think is also noteworthy, right? So I think the punchline for me is also, if younger adults are keying in on utility, that's just a matter of time for social robots. They're going to have the skills too. So at some point, that's going to be moot. And then it really is about these other aspects. It is about this other relational AI aspects. And that technology, to me, that says that in the long run, social robotics are going to be the next thing, right? Because it can't just always be disembodied talking speakers, right? Clearly, that's going to be the glide path. And we're starting to see it in this engagement data. And again, it just gets down to the way our brains work, We evolved to want to connect and relate to animate entities in this way. And, the more you design to support that, the richer the engagement, right? So I think it's not surprising when you think about it that way, but I think the industry has to kind of catch up. I think right now our spoken language systems are very much like playing chess. It's like discrete turns, but communication, human communication it's a dance. It's not playing chess. It's mutually regulated, it's dynamic, it's fluid, it's all of these things. And that's where all of these other things like liking and trust and affiliation come to play. So.
Given the chance.
Oh, okay.
I'm just, maybe this is projecting way too far in the future, but I remember reading an article where it was said that dogs have been bred to the point where they prefer the company of humans to the company of dogs. Mm. And so it's not that far a stretch to think that eventually the social robot will be socially far superior to other humans, and then humans may start preferring the company of robots to the company of humans. And how far in the future do you think that is?
Yeah.
We have already observed.
So I will say this. People need people. We need to feel that we belong to our community. We need to feel valued by our community, that our community cares about us. We can't flourish if we don't have that. And so I think these robots and these intelligent technologies are going to be, a wonderful augmentation of society, but people still will always need people. And these technologies should be designed to enhance and support that,
I'm not sure I get your premise. I mean, it's certainly not true for dogs.
Well, but I'm not talking about the dog. I'm talking about what it is to be human. Humans need humans. I'm not saying dogs can't be bred to prefer humans over dogs. I'm saying the way human beings are by our very nature. We are profoundly social species, right? We've evolved to need, social pain is now being appreciated to be real pain, right? It's not just this kind of stiff upper lip thing. It's processed in the same regions of the brain as actual pain. We're just, chronic loneliness is as serious of a health condition as smoking and obesity and substance abuse. It's like we're just starting to really appreciate the neuroscience of how deeply social we are. So people need people.
You're making the premise of what you're saying is based on the fact that we will never have more empathy for robot than for human. Is that correct?
I think that human relationships are complex and messy and important, and they make life worth living. I do. There's something about the human-human relationship that I don't think you're going to be able to replace with a machine. I don't think you can't create machines that are going to help benefit people in profoundly important ways, but I don't think they're going to replace what's important about human connection to people. And I'd be willing to say I think the neuroscience is going to show that.
I have a related question. Would it be fair to define social robotics as robots with social skills?
So, I think like all aspects of robots, you can probably put, a panel of experts on social robotics and probably give you different definitions of what a social robot is, just like they're going to give you different definitions of what a robot is. So they absolutely have social skills. I would say it's beyond that, though. It's that they are engaging. It's how they engage people, right? They are engaging these social thinking, reasoning mechanisms of a person.
Would it be fair that they operate in a way, in a form of social engineering?
I don't know. I don't understand. A form of social engineering? I mean,
right. Manipulation through the simulation of social or human-like social skills.
So I would say that absolutely. So as they are designed, the human mind engages with them in a way that we've evolved to be, and you can design these systems to use that to benefit people.
And I guess that Patrice's comment was insofar as there's the danger of manipulating our plasticity. So the question is, there was this video about what was it, the ledger, the selfish ledger that Google released so far. Who is motivating the social robots to act on our behalf?
This is what's so important to discuss. Yeah. So whether it's virtual reality and people's vision sensors being stimulated like it's the real thing, or whether it's advertising or cinema, we're not strangers to artifacts manipulating us, right? We do this all the time in many, many different capacities. Our games, our advertising. This is not the new thing.
No, but
it's just to say that it can happen here as well, and we need to understand it, and we need to have dialogues around best practices and how it should be applied to benefit people. Because clearly, the good news here is that it can really benefit people, but you don't want unintended consequences, right?
I love you saying this, because this is a very perhaps subtle atomic bomb. So you're saying let's have children interact with robots that are experts in social engineering. Go. So having that running without the concern of people like you will be dangerous. So,
and I would say it's like any time you're trying any form of learning, right? Designing a serious game, right? I mean, what this is a different dimension of designing technologies that interface with the human mind and behavior, right? That's what all of this is essentially about, right? And it's to say, just like too much screen time. Right now, people are willing to say that screens can be addictive to kids, right? It's to say eyes wide open with any technology, with any age group. I wouldn't say it's just kids, with any age group. Tremendous benefit is possible, but you got to keep eyes wide open. Absolutely. So you wanted to ask a question.
Yes. The charts. How did you measure and benchmark empathy? There were like multiple charts in which empathy was shown.
So this was literally like a personality test that you would give to people that people filled out for the agent. So there was like standard questions asked on a personality test is what that represented.
So the people measured empathy based on their understanding.
So people were asked a question, like here's a set of questions, how would you rate the agent? Just like if you were taking a personality test for yourself, fill it out for yourself, they were doing that for the agent. Here's a set of questions, how would you fill it out? So that's what that was generated from. It was literally like a personality test, but just people applied it to the agent.
I'm curious, have you noticed maybe an analogy with the uncanny valley with social interactions? Like, have people kind of recoiled like that's too realistic or kind of been weird to have?
Yeah, so the uncanny valley, I think, is something that, people throw that term out a lot. Really what it means is the more human-like something becomes, you go into this kind of, feels creepy kind of factor. So I think, for me, a more recent example is, human animated characters in film. At the time of like the first tin toy, Pixar, I don't know if you remember the baby in the concrete diaper, way in the valley, way in the valley. But then at some point, Shrek, whatever, clearly we could tell that it wasn't a real human, but the aesthetic was out of the valley, right? So something as abstract as Jibo isn't really something that's going to fall in the valley because it's meant to be how exactly human-like it looks is kind of what that conjecture is really about. But I would say that when you ask people, creepy can mean any number of things to people. It could mean creepy because it seems so lifelike. To another person would make it seem really cool, right? And then there's kind of creepy, like walking corpse creepy, which is, that's what the uncanny valley, I think, was really getting at.
Let's do one more.
I just have a quick question. When do you think Jibo will get arms and legs? Like as these, like we have all these Alexas and all these like speakers that are stationary, but when do you suppose?
So I would say, when people ask me what a social robot is not something that only sits on your countertop. I happen to build those systems because I want to focus on the social, but I would argue Baxter is a social robot because it was designed to work collaboratively with the person, and it's got the screen with the eyes and the attention. It's a social manufacturing robot. So, Toyota Research, other people are going to create mobile manipulator social robots because they have to live with people, and it's that social interpersonal competence that's going to be critical for it fitting into people's lives and them wanting to have it around and for it to actually being collaborative and helpful. So, I just think it's, it's all going to happen. Okay, can you, yeah.
I thought it was interesting that the interaction was sort of better when the robot switched from being expert to novice, because I think a lot of us do like robot as a student or robot as a teacher, but sort of doing that. But how did you decide what exactly an expert or novice meant? Because I think the way we interact with each other, there's like a graded scale of how we're an expert and how we're a novice.
Yeah, so there were specifically different behaviors that the robot would do in either role. So a novice role, the robot may ask a question. And the reason why it's really asking the question is because it wants the child to articulate, because that's going to help them learn, but it's playing the role of the novice. Or in the novice role, the robot would intentionally make a mistake and ask the child, why do you think that was wrong? So like those are examples of like novice behaviors. Expert behaviors would be things like, giving the definition of the word or giving the child a hint. Right, so in this particular implementation, there were just different kinds of behaviors the robot would do in one role or the other, and we used reinforcement learning plus some adaptation to switch the roles dynamically based on, how the child was doing, both from a kind of effective computing standpoint as well as their actual performance in the game, right? So the robot was always making decisions based on how do I best support this child in this moment, even as it was kind of taking this different kind of role. But what we definitely saw anecdotally was children kind of, they became a little more of a lean back experience when the robot's behavior was predictable and it always kind of took one role or the other, whereas when it was mixing it up, they noticed more. And what we also found, again, the social modeling thing, is the more the robot talks about its own process, the more children talk out loud about their process. So we see this social modeling happening again and again in so many different constructs. And in this case, it's obviously done in a way to promote the children's learning, because the more they articulate and reflect and verbalize, the more likely they are to actually learn these things, right? So
And in each role, is the robot learning what to say? Because I could imagine, like in the future, to have some sort of like hierarchical behavior, trying to figure out.
So it's not learning on the fly. How to generate. I mean, there's a set of kinds of parameterized utterances it's going to say. So it's kind of more templatized of these forms. In the future, yeah, you can imagine having that be much more flexible. But in the case of this particular work, it was more templated kinds of responses. Okay? Good?
Thank you again, Cynthia.
Great, thank you.